Okay. Today is the second week from our course. The classes are independent. So today, the subject, the topic that we're gonna see together is word problems modeled with linear equations. Okay, we will see the theory involved and 35 practice questions. Okay. Okay. So a step-by-step guide to modeling real-world problems or word problems with linear equation, translating English into algebra, solving one variable equations, and setting up system of two equations is what we're going to do today. Yeah. Followed by 35 practice questions, 10 easy, 10 medium, 5 medium hard to prepare to 10 hard. Yeah. With hidden step-by-step solutions that we can check. Written for Pre-Algebra and Algebra I. Students at SOMATH. Was that okay? Super easy? Yep. Okay. Okay. Who this is for? Pre-algebra and algebra 1 students who can already solve equations like 3x plus 5 is equal to 20 mechanically and do this very well, but freeze up when the same equation is buried inside a word problem about apples, coins, trains, whatever. Nearly every algebra state test and standardized test exam is more than half word problems. The math is easy. The translation is the hard part. Is that okay? Yeah. This lesson gives you a repeatable 5-step recipe, then 35 progressively harder problems to practice on. How to use this set? Read the theory first. Then work through each question with paper and pencil. It's very important that you structure in the paper diagrams, okay? Or what you consider that is properly to you visualize more comfortable as possible the question, okay? Before you click. So you have all the solutions hidden. The point is not to read solution. The point is to build the reflex of turning English into equation. If you get stuck for more than 5 minutes, okay, in a question, click to see the answer, check the answer, read the explanation, then close again and do by yourself. Yeah. This helps, okay? We have these sections to see today. Okay, the theory, the 5-step recipe, translation table, English to algebra, then the sections that we go over the questions. Theory, the 5-step recipe. Every linear equation word problem, whether it is about coins, age, mixtures, or trains, is solved with the same 5 steps. Do them in this exact order. Step 1, read once for the story, once for the numbers. Okay, when you develop an expertise in word problems, you don't need to read twice because in certain questions it's a waste of time. And for example, in the GMAT questions, you have a bit less than 2 minutes to do it questions. You don't have time to read twice, okay? But when you are building your foundation for algebra, it's better you read the word the words that you read to attack the numbers, to make the numbers, the operations, the constants, the variables more evident to you. Okay? The first read is just to understand what is happening. The second read is for the numbers, the units, and the question at the end. How many? What is there? When will? So when you read, before you answer, even if you did everything, okay, read the last time what is being asked. Because sometimes you interpret something and in fact you misunderstood. And in the options, this is not rare, in the options, you find the answer that you thought it was, but the author of the question is trying to trick you. Is that okay?
Yeah.
Okay. Underline both the given numbers and the question. Okay. Name the unknown with a variable. Generally, we attribute the unknown to X. Okay? Pick a letter for the thing the problem is asking about and write down what it means in a sentence. Something like, let's X the number of dimes, the quantity of dimes. If there are two unknowns, name both. But name both if they are different with different, obviously, variables. Okay? Rule of thumb. If you can express the second unknown in terms of the first, for example, the number of dimes is 3 more than the number of nickels. So dimes is equal nickels plus 3. You reduce in a second phrase for this equation word problems, okay, the quantity of variables. So our job in algebra is reduce as much the quantity of different variables that we have. So sometimes put one of them in terms of another. Okay? Like here, the dimes is in terms of the nickels. Is that okay?
Yeah.
Okay. Only use two variables when the two unknowns are truly independent. Okay, if you can relate them, always try to relate them. Step 3. Translate every sentence into algebra. Now go back to the problem, sentence by sentence, and write and write each fact as an equation or an expression. Okay? Words like is, equals, the total is become this symbol. You know that. Is that okay?
Yeah.
Words like more than, increased by, sum of becomes addition, the operation. Okay? Words like less than, fewer, difference become minus or subtraction. Is that okay?
Yeah.
Use the translation table in the next section as a cheat sheet. Okay. Step 4. Solve the equation or system. Now the algebra is just algebra. For a single linear equation, for example, linear equation that we will see together. Ax plus b is equal c. Is that okay? Subtract b from both sides, then divide both sides by a. Okay, let's talk a bit about this. Ax plus b is equal c. I will pass b. What is my job? Isolate in the left side the variable that is x. So the first thing that I'm going to do is pass b to the other side. Here in the United States, even when you know very well equation, how to deal with equation, they continue to do, oh, subtract b here and subtract b here, because what you do in a side, you need to do in another side. This is a total waste of time. Just pass to the other side with the opposite operation. If it's adding, you pass subtracting. Do you agree?
Yeah.
Okay. And A is multiplying. Do you agree?
Yes.
So you pass dividing. Okay. You don't need to do, divide one side by A and other side by A. My God, this is a total waste of time. Is that okay for you?
I mean, it's a little bit more confusing, like without that.
I will give numerical examples. Okay. Let's suppose you have 3x plus 4 is equal, let's see, 70. Is that okay?
Yeah.
What is the first thing that you're going to do?
Subtract 4.
Do you agree?
Yeah.
This is not the same because what you're going to do? Plus 4 minus 4? 17 minus 4?
13.
Okay. That is 13. This is not exactly doing this. It is or not?
It's not the same thing.
It's not?
No, it is.
3x plus 4 is equal to 17. 3x is equal to 17 minus 4. 3x is equal 17 minus 4, 13. It's not the same exactly thing that we did. 3x plus 4 minus 4. 17 minus 4. 0, 13. It's exactly the same thing. So the rule is pass to the other side with the opposite operation. What is the opposite operation of addition? The subtraction?
What?
The subtraction?
Yeah, that's opposite.
What is the opposite? You just said to me, what is the opposite of addition?
Subtraction.
The subtraction?
Yes. The addition.
Multiplication?
Division.
Division?
Well,
Power?
root.
Root? Root?
Power.
Okay, if you want to continue, this is for elementary school. I don't know why in the United States they continue to say, do always the same thing. It's a waste of time. Pass to the other side, from right to the left or left to the right, with the opposite operation. Okay, try to practice this. It's very important. Okay, it's like you do calculations since your first grade the same way you do in the 12th grade. You don't evolve. Okay. Okay, we'll practice that. Just a second. So, step 5, okay? Check the answer against the story. Okay, so just going back, here I maintained the American way because we are studying American core course. For the state standardized test, they will evaluate you along the way for the college. Okay, but it's the same that I did for you. Instead to plus plus, just pass plus. Okay, instead to do all the time, you know already that.
Yeah.
Okay, I'll give another example very fast. Mix a number. 3 and 1/3. 3 and 1/3 is 3 plus 1/3. You need to take the least common multiple, that is 3, between 1 and 3. Divide by 3. Divide by 1 is 3, times 3 is 9, plus divide by 3 is 1, times 1 is 1. So this is 10/3. Is that okay?
Yeah.
This is the explanation that you have a whole number plus a fraction. So the addition, you need to have the same common denominator. I did step by step, but there's a better way. When you know that, you multiply by the denominator, sum the numerator, and divide by the denominator. Look, 3 times 3, 9, plus 1, 10 thirds. Is much faster. And in math, okay, when they teach you something, you need to know the demonstration, where this comes from. But when you practice, when you solve questions, you need to go for the faster way. So when you deal with equation, doing plus plus, minus minus, divide, okay, is much longer, okay, than pass through with the opposite operation. Is that okay?
Yeah.
It's like gaining maturity in math. Okay. Just a second. So let's go back. Let's continue and go for the step 5. Check the answer against the story. Plug your number back into the original, okay? Sometimes you find the equation and then find the number that solves that equation. You need to verify many times, like check if it's true, because sometimes you find solutions and when you substitute, you find some inconsistencies. Okay, doesn't work. We will see that in the future. Okay, but you get the answer and you plug back to see if it's true or false. Is what he's saying here. Plug your number that you found back into the original word problem that you found, not just the equation you wrote. Okay? Does it make sense? Okay. In fact, it is in the equation that you wrote. If the problem asks for a number of coins, is your answer a positive whole number? What he means, sometimes you find a solution, like how many coins you have. And let's suppose he gives you a quadratic equation. And the parabola passes in the left side of the zero, that is negative, and the right side that is positive. You get only the positive answer because there's no negative number of coins. But if I'm asked the same question, how much money you have, sometimes the negative is true because you are in debt. Is that okay?
Yeah.
So you always need not only check the question, plugging back in the equation, inequality that you found, function, etc. But consider if it makes sense. If it makes sense. Is that okay?
Yeah.
Okay. If it asks for a speed, it is reasonable speed. I don't know. Sometimes a car and you find that it's 1 million meters per second. Something is wrong in your calculations. Do you agree? Okay. A wrong sign answer or fractional child is a signal that you translated something backwards. Okay. Let's see the vocabulary that the authors of the questions put to you read. Okay. Everything is being recorded and you receive the recordings, okay? To check again, and you have the page that you can go over the questions again and do everything again. Don't worry. A number, some, how many, okay? A number, some, how many? You put X, you put Y. For example, a number, it's a variable. Some, it's a variable. How many? It's a variable. The sum of X and Y, X more than Y, X more than Y, X increased by Y. Is that okay?
Yeah.
X plus Y. X less than Y. The difference between X, Y, and X. Y decreased by X. Okay, here we foreigners. Are you American?
Yeah. Yeah.
I'm not. So we foreigners, we have problem on this. I will show you why. X less than Y. Look, is Y first. X less than Y is Y minus X. So be careful with this. Okay, so x less than y. Okay, the difference between y and x, so y minus x, and y decreased by x, so you get x and decrease y. Okay, so is again y decreased by x, so y decreased by x, you get, okay, you have y and you get x and decrease in the y. So be careful with this. There's another one that is subtracted from. For example, y subtracted from x, or x subtracted from y. Everything we're gonna see, okay, together. Let me create space here. Twice, double, two times, three times, triple, half, split in two, x divided by 2. Do you agree?
Yeah.
Okay. The product of x and y, x times y. Is that okay?
Yeah.
The quotient is the result of a division. It's called quotient. Is that okay?
Yeah.
Is equals, the result is, the total is equal. Consecutive integers. Okay. What is an integer? An integer represented by the z letter. To you memorize, I used to make a joke. Zinteger. Okay, is from minus. Oops, sorry. Is from minus infinite, 0 to plus infinite. You have here the integers. Okay, I can represent generically them by this. X, the next you add 1, the next you add 2, the next you add 3, and so on. This is the way, the generic way that I represent the integers. Is that okay?
Yeah.
Consecutive even or odd integers. Okay. There's something that we will evolve from this notation, but look, if x is an integer, the next one is x plus 1. If I am listing odd and the first one, sorry, even, 2, 4, 6, okay? If I'm representing an even integer as x, the next one is x plus 2. Then x plus 4. Do you agree?
Yeah.
For example, 2. Then 2 plus 2, 4. 2 plus 4, 6, and so on. This is not the correct exactly way to represent. Okay, we will see that is 2x and the odd is 2x plus 1 in the future. Okay? Okay. But for now, we stay with this notation. Okay. Any years from now, add n to each age. So Charles has 14 years. Any years from now, 14 plus n. Okay? Or n plus 14. Any years ago is subtract. Okay? He had 20 years. But any years from this age, so is past. So it's less than 20 years. Do you agree?
Yeah.
Okay. Distance, rate times time. We have a special chapter for this. So you know rate, that I can say speed is distance over time. Do you agree?
Yes.
So if I put distance, if I put speed as rate, okay, I will pass multiplying, so distance will be RT. Is that okay? Look, was dividing, I passed multiplying. Okay? So Downstream speed, boat plus current. Okay, if you are rowing the same direction of a stream, a current, you is easier. Okay, so the total speed is the speed of the current plus the speed of the boat, or how much you are rowing. Okay, but if it's the opposite, okay, is the speed, and I suppose that you are winning the current, is your speed minus the current. Is that okay?
Yeah.
Okay. We have a special chapter for this, work rate. The rate of a work is how much you build the work, doing the work over time. Okay? We have a special chapter to talk about two people working together. Okay? Three people working together. Two people working together, one stop, then you add another one and calculate through the rates how much time does it take to finish that work.
Yeah.
Or in a certain time, how much of the work was done. Okay? P% of X. P%, okay, of is always multiplication. Is that okay? P% times X. Okay? All these expressions you need to be used to go over Algebra 1 in your life. Is that okay? Total value, price times quantity. This I will talk a lot. I used to say quantity times value is equal amount. This is very important for us. Let's suppose each bird costs $3 to feed per day. I have 30 birds. This is the total amount that I spend every day feeding the birds. Is that okay? Look, quantity times value. What is this quantity? Is the quantity of birds. What is the value? Is the average value that I spend every day to feed one bird. Okay, so as I have 30, I need to multiply by 30. Is that okay?
Yeah.
Okay. So we saw everything here. Okay, with step 2, name the variable. Step 3, translate. Step 4, solve. And the vocabulary above, you can solve every single problem below. Try each one on paper before revealing the solution. Okay, so the step 1 is reading. Then you go 2, 3, and 4. Okay. Okay. I would like, just a second. I will give you 1 minute to try this number 1 question.
I believe it would be 17. The number would be 17.
Let's see together. a number that I don't know plus 7 is equal to 23. Instead to do this, that is a waste of time. 7 is adding. You pass subtracting. 23 minus 7?
Yeah, that's how I add 23 minus 7.
How much is 23 minus 7?
17.
So x is equal to 17. Do you agree?
Yeah. Oh, 15.
Okay. 23 minus 7 is 16. Okay. Don't miss a question because you neglected a very simple calculation. Is that okay?
Yeah.
Okay. So it's 16. Okay. If you want to check, as he said, you don't need. It's here explained, but you don't need. Okay. You need x plus 7 is 23. Plug here. 16. 16 plus 7 is 23. So the sides are equal. Is that okay for you?
Yeah.
Okay. Next one, please. Pay attention, okay? I will give you 1 minute more.
That would be 23.
Twice a number. Twice a number is 46. So if it's 2 is multiplying, you pass dividing. Okay, you don't need to do this. Okay, you waste time. Okay, yes, 23 because 6 divided by 2 is 3, 4 divided by 2 is 2. Is that okay?
Yeah.
Easy?
Yeah.
Next one, please. Go ahead.
Do it, 9 times 5 equals 45, minus 4 would be 41.
Let's do it together. 5 times a number minus 4 is equal 41. Okay. I have minus 4, I will pass plus 4. 41 plus 4 is 45. Is that okay?
Yeah.
5 is multiplying, I will pass dividing. 45 divided by 5 is 9. Is that okay?
Yeah.
Okay?
Yeah.
Next one.
Twenty-seven.
A number divided by 3 gives 12. 3 is dividing. I will pass multiplying.
We're doing number 4.
What?
So we're on question 4.
Well, we did the 3. Now is 4.
My bad. So I was looking at number 5 first.
No, do the number 4.
$36.
Exactly. So let's do it. A number divided by 3 is 12. 3 is dividing. I will pass multiply. Where is it? Back here. It's better you do in the way that I do.
Okay.
It's better you do in the way that I do. Okay?
All right.
Because it's much more efficient. Okay? There's a girl that came here and their parents going to 5th grade, and the parents reported that she liked the class, the sample class that she participated, but she would not enroll because she didn't understand what was saying. It's not true because she was responsive all the time. Okay, but to you be here, you really need to know the purpose to be here. Okay, that is no math. That is the most important extracurricular thing that you can do for your life before college. Okay, this is the number 1. The number 2 is, as she was responsive, she was getting what I was saying. What was the problem? The problem is, if existed, is I say the things the concepts, the definitions, different from the teachers that you have in school. And this is exactly the purpose here. Okay, so I'm telling to you, I'm seeing your diagrams in your paper. You will suffer because you are doing in an arithmetic way. It's generally how the teachers here do. The teachers here, they don't study math in undergraduate and masters. They study in an educational school, generally. Okay? So they don't know the rigor, the patterns of math. I'm telling to you, structure the concepts the way that I'm structuring. The way that you are doing is so much more arithmetic than algebra. Okay? You did the next one. What was the answer?
The one for number 5 was 27.
Let's see. Anna has some stickers. Her friend gives her, so I don't know how many stickers. X. Her friend gives her 15 more, plus 15. And now she has 42. How many stickers did she have? Okay. As 15 is adding, I will pass subtracting. 42 minus 15 is 12. 7 here to 27, like you said previously. Is that okay?
Yeah.
Okay, but the structure should be this. Okay?
Okay.
So, yeah, we are not here only to kill the questions. We are here to produce patterns, concepts. Okay? So 36, as you said, and 27, as you said. Okay. Next one, please.
X equals 9.
We are doing the 6, right?
Yeah.
A pencil costs 2. Okay. Lucas buys some pencils. Okay, I don't know how much. So 2 each, I don't know how much. So the total spent is 2x. Do you agree?
Yeah.
Okay. And spends a total of 18. So the price of each one times the quantity of pencils is 18. So S2 is multiplying, you pass dividing. 18 divided by 2 is 9. Is what you said?
Yeah.
Question number 7. Let's go.
X equals 7.
A number when increased by 8. A number when increased by 8. And then double. Equals 30. A number when increased by 8 and then double. So first to increase by 8, you need to imagine. First to increase by 8, then double. So you need to put parentheses. Okay? Do you agree?
Yeah.
X plus 8. 2 is multiplying. You pass dividing. 30 divided by 2 is 15. Do you agree?
Yes.
8 is adding. You pass subtracting. 15 minus 8 is?
7.
Is that okay?
Yeah.
This is what you answered?
Yes, but I did like by figuring out like
Huh?
I figured it out by doing having like 30 and then divide that by 2 is 15 and doing 8, essentially 8 plus 7 or 7 plus 8 got 15. And thus that got 30.
Where is it? You need to solve that. You need to follow my pattern, okay? Try. You don't need to accomplish now, but you really need to try. This is elementary school. Okay? Number 8. Go ahead. Three times a number. 3 times a number.
Yeah.
Equals 20 more than the number. Three times the number equals 20 plus the number. 3x minus x is equal to 20. I pass to the other side. 3x minus x?
Just X. Oh no, where you X? 2x?
Because here is 1. Okay?
Yeah.
2x is equal to 20. How much is x?
10.
Because 2 is multiplying, you pass dividing. Okay?
Okay.
Okay?
Yeah.
Write it down, the equation. Just the equation.
For 8 or 9?
8.
Oh,
Number 8.
3x plus 8. Equals.
No. Read again, be calm. Okay? Read and do it. Done?
I have the 3x equals 1 plus x. I'm working on the rest.
Everything that has x, you pass to the left side.
That. Very good.
9. How many numbers you have? How many numbers that you don't know you have?
2 here.
2. You put 1 as x. Is that okay?
Yeah.
The next one is related to the first one. And he says is consecutive. How I write the second one as a consecutive of the first one?
X plus 1.
Yes. How are they related in terms? Look at the screen. How are they related in terms of operation?
The
Do you agree?
addition.
Yeah. Okay. What is the result? Do you agree?
Yeah.
So 2, the sum of 2 consecutive is equal 47. X plus x
X squared. Oh, no, no, 2x.
is not x times x. Okay? 47 minus 1.
46.
Okay? Find a smaller. 23. Is that okay?
Yeah.
And the next is 24, obviously. Okay? Do you see how is the diagram is made? Okay. The homework is to you to do everything again. And you need to diagram the same way. The layout needs to be equal. When you see this information here, EA is it est, is Latin. That means that is. So this, that is this. Okay?
Got
It est. That okay?
it. Yeah.
Next one. Question 10. Need help?
No, I think x equals 5.
Let's see. A taxi charges 3. You need to pay 3. You need to pay. Plus 2 per mile. Do you know how many miles?
No.
So I put M. Okay? 2 times the number of miles. The total fare will be 17. Is that okay for you?
Yeah.
You need to build in this way. 2M is 17 minus 3. Do you agree? Because I'll pass 3 to the other side.
Yeah.
14. M is 14 divided by 2 because 2 is multiplying. 7. You said 5.
Oh, 5. Oh.
Okay? You need to do in this way. If you don't do in this way, it will be hard. Okay? As I said, I'm not expecting you change, you shift now.
Yeah.
Okay? We have 1 year to do that. Okay? So try to do in this way. You see, I build the same way that he builds. Okay? Okay, now we are jumping to medium level questions. Okay? Are you prepared?
Yep.
Do the question 11.
Mr. Marcello, you might scroll down a little. Can't even go in.
Oh, something went wrong. Just a second. It's a glitch. Okay. Just a second. So the problem is here. And we are back. We are going to the number 11. Do you agree?
Yeah.
Okay. Go ahead. Want to help?
Yeah. Yeah, what about putting x plus then x plus
How many numbers that I don't know I have in this question 11?
3?
One can be x.
Yeah. But one.
The other one can be x plus 1. The other one can be x plus 2. I am adding all of them. Okay?
Yeah.
And the result is 72. Is that okay?
Yeah.
Look to the screen. X plus x plus x.
3x.
1 plus 2.
3.
What do I do now?
Bring down the 72.
Say the calculation.
3x equals 72.
No.
3x.
What I do now? What is the operation that I do now?
Add
72 minus 3.
72 minus 3 is going to
Be simple. 72 minus 3. How much?
59.
What I do now?
Divide by 30.
Divide what?
Divide 69 by 30.
Great. That is?
20.
Is that okay?
Yeah.
Be simple. Always simple. Read, be simple. Math is not complicated. The problem in math is there's no sense. There's no logic. You never understand. You just need to accept.
Yeah.
Okay? Who says this? Oh, it's logic. It's not. There's no logic on this. Okay? So 23, good for you? Okay?
Yeah.
So it's not more advanced. Maybe we have one step more. Okay? But it's the same pattern always. We are trying here to create pattern. Why? Algebra is used to create patterns in arithmetic and make arithmetic predictable. Okay? Okay. Oh, find the three integers. Sorry. The smallest one is 23, so the next one is 24 and 25 because I have three consecutives. Is that okay?
Yeah.
Okay. Next one. If you need help, let me know.
I think I might need a little bit of help. I put like 4x plus 5.
Okay, let's do it together. A father is currently 4 times as old as his son. Okay, pay attention. Do you know the age of the son?
No.
X. Okay? So, you don't know the age of the father as well. But you know how many times the age of this father is related to his son. How much?
He's 4 times as old.
4x.
4x.
Is that okay?
Yeah.
In 5 years, the father will be 3 times as old as his son. 5 years. The time passes to the son and the time passes to the father. Do you agree?
Yeah, I have 4x plus 5 and it has an equal symbol.
So, in 5 years, the father, in 5 years, will be equals 3 times as old as his son. Is that okay?
Yeah.
I do everything again. Pay attention. A father is now 4 times as old as his son. Okay. I could have done this. Father is 4 times son. But I can, since the beginning, reduce to one variable, one in terms of the other. Okay. So is what I'm going to do. So if the son has X years old, the father has for X. He's telling he will provide a relationship between their ages in 5 years. So 5 years for both.
Yeah.
Plus 5, plus 5. Let's see what is this relationship. Okay. In 5 years, the father in 5 years will be 3 times as old as his son in 5 years. Okay. How old is each now? Now you solve. Pay attention. For x plus 5 is equal. Here I need to distribute 3x plus 15. Do you agree? 4x minus 3x. Do you agree?
Yes.
How much?
It's going to be 7x.
I repeat. 4x minus 3x.
1x.
15 minus 5.
15 minus 5 is going to be 10.
So the son now, the age of the son now is 10. So the father, that is 4 times now, is 40. So 10 and 40. Do you agree?
Yes.
Here's the whole solution, the whole explanation, okay? You really need to study, okay? Let's go to the next one. Need help?
Yeah, we're going to an arithmetic group, and I know you said not to do that. I'm figuring out how to.
One number is 8 more than another. Do you know how much is this one number? Do you know?
Oh, never mind. I'm sorry. I was looking at 14 for some reason. I don't know why.
Devin,
Yeah.
it's always on the top.
Oh,
Do you need time to do it? The 13?
yeah.
So do the 13.
I'm trying to make that mistake.
It's always what you see on the top. Okay? When we finish, I do this. Okay?
All right. Thank you. When x equals 56.
Okay. Do you know how much he says? One number. Do you know how much is this one number?
No. So it's x.
X. Is 8 more than another. So I will put X, the another, and this one number, X plus 8. Is that okay for you?
Yes.
Okay.
Then equals 54.
Their sum is equal 54. 2x is equal 54 minus 8. How much is 54 minus 10? Is 44 plus 2, 46. So x is 23. So if this is 23, this is my God, 31. Do you agree?
Yes. Yeah, I made a mistake when I added a second x.
X plus x, 54 minus 8.
Got it.
Is that okay?
Yeah.
14. Let's do it.
Okay.
A rectangle length width. A rectangle length is 3 more than twice its width. Let's suppose the width is x. The length is 3 more than twice the width. Is that okay?
Yeah.
If the width is x, the length is 2x plus 3.
Yes.
Here, we don't have parentheses, okay? The length is 3 more than twice the width. The perimeter is 36. What is the perimeter? The sum of all the sides.
Yes.
This side is 2x plus 3. This side is x. So I have 2x plus 3 times 2, because I have 2 of this. Okay, or you can do 2x plus 3 plus 2x plus 3. Whatever, is the same thing. Plus 2x, or x plus x. Is that okay?
Yes.
Is equal to 36. Okay. I will distribute here. 4x plus 6 plus 2x is equal to 36. 4x plus 2x is 6x. 36 minus 6 is 30. X is 30 divided by 6, that is 5. Okay? So, if the width is 5, the length is 2 times 5 plus 3, 13. Do you want me to do again?
No. Kind of reading that. Yeah, that makes sense.
Can we go?
Yeah.
So it's 5 and 13. Okay? $15. Let's do it.
What?
Let's do it.
Yeah.
Are you tired?
No, I'm thinking this out.
Martha buys 3 notebooks and 2 pens for 19. Do you know how much each notebook costs?
Each notebook costs 3 more than a pen, but we don't know how much it costs.
So I know I have 3 notebooks and I put n to the unit cost.
See, that's right. I did 3n plus 2p equals 19.
plus 2p is equal 19. A notebook costs 3 more than a pen. A notebook is a pen plus 3. Do you agree?
Yes.
What is the price of a pen? Okay. This is a system of equation for the first time that I do through substitution. We will see many times that you can solve a system of equation in two ways, substitution or elimination. I like much more by elimination, but here is already prepared to you do by substitution. So I will not transform this in an elimination. I could, but I will do by substitution. What I'm gonna do? 3. Do you agree that n is p plus 3?
Yes.
So I will substitute here. 3p plus 3 plus 2p is equal 19. Okay? I will distribute here. 3p plus 9 plus 2p is equal 19. 3p plus p is 5p is equal 19 minus 9. That is 10. P is equal to. Okay? So the price of a pen is 2. So the price of the notebook is 5. Okay? Next one. Yeah, this, I don't know. Are you figuring out?
Yeah, I'm trying to figure it out. I'm kind of like struggling with like putting like what I'm seeing. Like
Yes, because we have a whole chapter for this. Okay, this is a bit hard to figure out, but maybe you can do like not with a formula, but in an arithmetic way.
Yeah, cause I struggle to like put it into like the terms of like
Yeah.
where I'm writing the equation.
So, do you want me to do?
Yeah,
Okay.
I put 8 plus 50.
Okay, let's see this. Okay. Train A leaves the station going at 60 miles per hour. One hour later, B. Let's suppose the train A left the station at the time t, or the time t. I don't know how much. Okay. So the train we will travel the whole way, it will be, I don't know. There's something here that I need to explain to you that takes time, but I will explain now, but we have a whole chapter for this. Okay, here's the thing. I will continue to read, then I will establish the period of time they keep traveling until one overcomes the other. So the train B leaves the same station going at 75 miles per hour in the same direction on a parallel track. How many hours after B leaves in terms of B until B catch up A? Okay, here's the thing. I have a whole chapter, as I said, and I have a technique. I don't know how much time each one stay traveling until B pass A. But I will attribute that the time that B stays traveling is T. Is that okay?
Yeah.
I don't know how much is T. And I will put A in terms of T. The time that A is traveling until surpass, until overcome, until B overcome, okay? Until be passed by B, it will be T plus 1. Why? Because when B left the station, A was already traveling 1 hour, because B departs 1 hour after A departed. Do you agree?
Yeah.
Okay. So, what is the theory involved? The distance that A travels until be passed by B is the same distance that B travels. Do you agree?
Yeah.
What is distance? We know that speed is distance over time.
Yes.
So distance is speed times time. I pass, multiply. Do you agree? So the distance of A is the speed of A times the period of time of A. B is the speed of B times the period of time of B. I know the speed of A is 60. Is that okay?
Yeah.
The period of time of A is T plus 1. Is that okay?
Yes.
The speed of B is 75. And the period of time that B travels is T. Okay? Now we'll distribute here. 60T plus 60 is equal 75T. 15T is equal 60. T is equal 4. Is that okay?
Yeah.
So, the train B, that is T, stays 4 hours traveling until pass A. And A stays 5 hours because it's the same period of time, but the train B, was already traveling 1 hour. Okay, as I said, I have a whole class of 2 hours to go over this kind of questions. Okay, that I call distance problems. Is very frequent in tests, for example, the GMAT test, okay, for MBAs. So the answer is 4. Okay. 17. Go ahead.
has 20m, like big M, uppercase, then plus 0.10 lowercase m, representing the big M representing months and the little m representing minutes, and then equals 47.
Yeah, you don't need to do 20 times m because m is equal 1.
Got it.
You are calculating just 1 month. Is that correct?
Yes.
So it's 20 plus 0.10 times, I don't know, x if you want, is equal 47. Do you agree?
Yes.
Okay. Did you do
Yeah.
the calculation?
I showed that down. Calculation.
Okay. Done?
Figuring it out.
Okay, let's do it together. A phone plan charges 20 per month, 20 times the number of months. In the end, I discovered that it's just 1. Plus 10 cents per minute. I don't know the number of minutes. Last month, so m is equal 1. Okay, because it's just 1 month. The bill was 47. How many minutes? Okay. 0.1 m is equal 47 minus 20, that is 27. Do you agree?
Yes.
Now, I will divide 27 by 0.1. Instead to do this, I will do something easier. Okay? I will multiply the numerator by 10 and the denominator by 10 to not change the ratio. 27 times 10, 207. 0.1 times 10 is 1. So it's 207 minutes. Is that okay?
Yeah.
Number 18.
So this be correct. X plus x plus 1 equals 40.
Let me see. The sum of two numbers. Do you know if these numbers are equal?
We don't know. Oh, well, it says.
Do you know or not?
No.
So x plus y is equal 40. Okay? But now he will create a relationship between them, or it's impossible to solve. Okay? 3 times the larger, okay, 3 times the larger equals 5 times the smaller. 3 times the larger, I will institute that my larger is x, is equal 5 times the smaller. Okay? Well, I have a technique here. The majority of the people would isolate x and substitute here. You can do that. I will do that just to elucidate, because there's a better way to do, because the calculations will be easier. So x is 5y over 3. 5y over 3 plus y is equal 40. I need to take the least common multiple. Okay? Between 3 and 1 is 3. 3 divided by 3 is 1 times 5y is 5y. Plus 3 divided by 1 is 3 times y is 3y. Is that okay?
Yeah.
Is equal 40. It's better you look to the screen. 3 is dividing. I will pass multiplying. Here's 8y is equal 120. Or I will not even multiply. 3 times 40 is easier to cancel. 40 divided by 8 is 5. 5 times 3, 50. Is that okay?
Yes.
Find the numbers. So I have y is 15. So x is 40 minus 15. That is 25. These are the numbers. Okay? I have another way to do that. If here is 5 and here is 3, they are equal. 3 times 5 is equal 5 times 3. But I don't know the proportion. If it's 5 to 3, if it's 10 to 6. So I will put here z. So my x is 5z. And my y is 3z. Is equal 40. 8z is equal 40. Z is equal 5. Okay? So if z is equal 5, this number is 25, because it's 5 times 5, and this number is 15. It's the same thing, but I did in another way. Okay? All these ways you need to learn in the next 1-2 years. Is that okay?
Yeah.
Yes, this school is to you stay studying math once a week in class and once a week by yourself for 100 weeks at least. Okay? 19. Help?
No. I think I got it. It's gonna be one month.
1.5.
A 1.5.
Okay. Gym A charged 30 sign-up fee plus 25 per month. Gym B charged 45 per month with no sign-up fee. After how many months do the two gyms cost the same? So the break-even is the same kind of calculation. So Gym A is 30 plus 25 times the number of months. This is the total cost, okay? Gym B is just 40 per month. Okay, how many months until they have the same cost? So 30 plus 25M is equal 40M. 15M is equal 30, M is equal 2. Did I do something wrong? 40, 35. Well, it was 1.5. After how many months do the two gyms cost the same? Okay, or the question is wrong. Let me do it again, please. Gym A charges 30 plus 25 per month. Okay. Gym B is 45 per month. 45 minus 25 is 15. Do you agree?
Yes.
Is equal 30. M is equal 2. Let me check if there's a discrepancy. Uh-oh. Yeah, the solution is wrong. Look. Do you agree that we did the same thing here? But 45 minus 25 is not 20, is 15. Is that okay?
Yeah.
So I need to correct this. Let me just do something to correct. Sorry about that. Okay. Next one. Okay. This is the last one for today. Okay.
Okay.
Yeah, this is a bit complicated. Let's do it together. Okay. A ferry crosses a river in 30 minutes going with a current and 45 minutes against. Is that okay?
Yep.
So going to the current is 30 minutes. Against is 45 minutes. The ferry speed in still water is 12. So the speed is 12 miles per hour. Find the speed of the current. Okay. Okay. What we know? The distance to goal is equal to the distance to back. Okay. He goes from point A to point B, 30 minutes in the same speed that's 12 miles per hour. When he comes back, it's 45 minutes at 12 miles per hour. The distance is the same.
Yeah.
Okay. What is distance? Distance is speed. Is speed times time. Okay. Speed to goal, time to goal is equal. Is speed to back, time to back. Do you agree?
Yeah.
Time to go, 30 minutes. Time to back, 45 minutes. Speed is not 12 and 12. To go, okay, is 12 plus the current. It's helping. To back is 12 minus the current, because the current is against. Do you agree?
Yeah.
I distribute 30 times 12. 360. Is that okay?
Yeah.
360 plus 30C is equal 45 times 12. 540. Okay. I'm horrible in calculations. I need to be careful. Minus 45C. Okay, then I will pass everything to the same side. 45 is negative, I will pass positive. 45 plus 30 is 75C. Do you agree?
Yeah.
540 minus 360. 0, 6 for 8. Yeah, 8 goes 1 for 180. Oh my God. 180 divided by 75. Both by 5, I divide. 36. 75 divided by 5, 1 goes to 15. Divided by 3 is 12 over 5. So 12 over 5 is like 24 over 10, that's 2.4. 2.4 miles per hour is the speed of the current. Is that okay?
Yeah.
I don't know if I made any mistake. 2.4. Okay? So look, the solution. So we are finishing for today. We are missing many questions that you should do and check the solutions. Okay?
Yeah.
Here are the answers. Here the ideas covered and an overview. Okay? And today we had word problems model with linear equations theory, and we did 20 questions. It was this. Okay? Thank you very much. See you next week.
I'll see you next week.